When we talk about the application of logs, one might ask, why do we use logarithms? It seems to make things more complicated. Consider this function in the question. Let's say if this is the original function, why do we have to use log on this equation? Consider plotting this function on a graph. When x equals to 0, y equals to 5, and when x equals to 1, y is already 125. Imagine when x equals to 2, this number gets tremendously big in value, and so it's very hard to present this function on in scale. But because log deals with the power, the index, it actually shrinks the numbers by a lot, and it makes the relationship between x and y much more comprehensible and easier and presentable on graph. Now let's talk about this example. The figure shows a linear relation between x and log base 5 of y. When we talk about linear relation, in this case it's saying graphically it's a straight line, and the axes are not x-axis and y-axis, but instead we have x-axis and log base 5 of y-axis. In terms of algebra, we don't mean y equals to mx plus c anymore because the variables are changed. Okay, but now we have actually log base 5 of y for y, and x is still x. This is the linear relationship. And of course, you can make x the subject, and you still have a linear relationship, but the m will be a different m and the c will be a different c. So how do we use the graph to help us find the value of k and a, the constants here? Okay, so we start out with the original function. And because we want to have log base 5 of y, then we apply log base 5 on both sides. And because of this law, we break this up into two terms. And then we move the power to the front for this one. Now it forms a linear relationship. Okay, you see this is the new y, log base 5 of y, mx, because it's a variable, plus c. This is a constant, it's a constant. Now we're trying to find k and a here. And because the line actually passes through this point, then we can actually substitute. When x equals 0, the new y, the log base 5 of y equals to 1. And so this becomes here, but this thing becomes 0, right? And so we only have 1 equals to log base 5 of k, and so k equals to 5. Now I use the other number here to find a. When x equals to negative 2 over 5, log base 5 of y equals to 0 using this coordinate. So basically we use this equation here, we substitute this with 0, and log base 5 of k, we know that it's equals to 1, and x is just this number here, right? And so we try to isolate this, move this to the other side and move this to the other side. It actually means that, or the other way to look at it is you put a base 5 on both sides. These two will cancel out and we get the same thing here. Now because 5 to the 5 over 2 power is actually equals to 5 squared times square root of 5. So the answer would be 25 times square root of 5. So let's summarize a bit on the procedures of this kind of question. So first step, you apply log to the original function to get the desired variables. What are the desired variables? X and log base 5 of y. So we have to do some algebra here. And the next step is you arrange the terms so that it's easy for you to identify y equals to mx plus c. Okay, the vertical intercept, this one, and slope. It might help. And finally, you substitute the points on the graph to calculate the unknowns, or maybe using the slope or the vertical intercept may help.